Hello everyone, I am Dino, together with Joseph and Ryan. We are back for another YouTube video. Today, we will be presenting the procedures for the instrument variable. Let's begin. This is our Excel file. The gathered data is from ADB Statistics. In this presentation, we will use Vietnam and the variables, namely urban population, GDP, interest rate, inflation rate, and government expenditure from the years 2000 to 2017. Let's copy these variables and paste it in this data. So, we first set it into time series and transform the variables into logarithmic form, except interest rate and inflation rate. Reset and click the year. Now let's transform this into logarithmic form. But before running the procedures, we will introduce to you our suspected endogenous variable and the candidate instrument IV. Our suspected endovar is GDP log. There is a literature I found from JSTOR, Economic Growth with Endogenous Corruption, an empirical study, where he labeled GDP log in the model as endogenous explanatory variable. That's why we will use that concept that the transformed variable, which is the GDP log, as our suspect endovar. And we propose that government expenditure log be the candidate instrument to the suspect endovar. Now, we regress the variables excluding the candidate IV. So type reg urban population log, GDP log, interest rate, and inflation rate. Click enter. So this is the result. The GDP log, interest rate, inflation rate substantially explains 26% of the urban population in Vietnam between years 2000 to 2017 ceteris paribus. GDP log is negative and statistically significant determinant of urban population in Vietnam at 5% significance level. In other words, a 5% decrease in GDP log leads to a negative 0.7 in urban population in Vietnam in the years 2000 to 2017 ceteris paribus. Interest rate is negative and inflation rate is positive, but they are both not statistically significant determinant of urban population in Vietnam, since their values are much higher for the level of statistical significance. Now, let's proceed to test whether we have multicollinearity problem. Just command VIF. The result is 5.73. It means that our independent variables don't have strong relationship with each other since it is lesser than 10. Now, let's going to test if there is a heteroscedastic problem by commanding estat imtest, white. So the result is 0.1455. The value is much bigger than 5%, which means that the OLS is homoscedastic. Now, let's proceed to serial correlation test by using the Durbin-Watson. Just command estat, then d-Watson. Enter. The result is approximately 0.67. This means that there is a serial correlation because the value is not 0 and not equal to 2. Now, let's proceed to the modern approach, which is the new west. Just command new way. And then, input the variables, urban population log, GDP log, interest rate, inflation rate, comma, type log, and 1. Enter. Based on the result, GDP log is statistically significant determinant of urban population at 1% significance level, and the rest is still not determinant.
Good day everyone. So this time, let us test if our candidate IV is a strong and valid instrument. So first, we will test if it is valid. So step 1 is regress into bar with IV together with control variables. So in this discussion, our suspected in the bar that we are proposing is GDP log. And then our candidate IV is government expenditure log. So regress into bar, which is GDP log with government expenditure, the candidate IV, together with control variables, interest rate, and inflation rate. So in this test, our dependent variable is GDP, which is our suspected endogenous variable, and then we regress it with government expenditure log, which is the candidate IV, together with control variables. So again, we are doing this test in order to know if the candidate IV is relevant. So analysis for step 1. There is instrument relevance if IV is statistically significant to the endogenous explanatory variable. So by looking on its p-value, we can say that our candidate IV, which is government expenditure log, is statistically significant to our suspected endogenous variable, which is GDP log. So therefore, in this test, there is instrument relevance. Again, the instrument will be valid if the proposed instrument is potentially won't be related to all variables in the error term. Okay, and it should be statistically significant to the suspected endogenous variable. So let us now proceed to step 2 and step 3. Step 2 and 3 determine if our candidate IV is a strong instrument. So step 2, regress dependent variable with independent variable together with control variables. So regress dependent variable with GDP log um, together with control variable. To step 3, regress dependent variable with IV together with control variable. In this case, in step 3, just simply change GDP log with our candidate IV, which is government expenditure. So analysis in step 2 and step 3. IV is a strong instrument when its standard error is greater than the standard error of endogenous variable in step 2. So now we will just compare their standard error. So let me explain in this way. the standard error of government expenditure, standard error of GDP log. So as we can see, the standard error of government expenditure log is relatively larger than the standard error of GDP log. So as a result, we can say that government expenditure is both valid and strong instrument.
So, after doing all the steps in testing for valid and strong instruments, we will now proceed to Hosman's test for ingenuity. So, basically, it's the same step 1 from testing for valid and strong instruments. We regress the indivar, which is the GDP log, our candidate ID, which is our government expenditure, along with the control variables, which is the interest rate and inflation rate. Sure. So, after doing this step, we generate another variable which is called residual. So by doing that, we input predict R, yeah, comma, space receipt is residual. Enter. So now we have our R variable. Then the last step in doing the Hosman test is that we regress the dependent variable, which is the urban population log. So reg, then our urban population log with the indigeneity variable, which is the GDP log, along with the control variables, which is the, of course, interest rate and inflation rate. Then our new variable, which is the R. Hit enter. There you have it. So, as you can see, if the coefficient of the reduced form residual is statistically significant, then indigeneity is present. Which means that if our R, our residual, is statistically significant, then there is indigeneity. As you can see here, RR is statistically significant. There you have it. At 0.01. So, after this Hosman testing for indigeneity, it has been proven that there is indigeneity problem, but we already have a valid and strong instrument. So, our final test here is called the 2SLS model, or the two-stage least squares. So, when we do 2SLS, we input IV regress. Instead of reg, we put IV regress. Then we put 2SLS. And then our dependent variable, which is the urban population log here, along with the control variables, which is the interest rate and inflation rate. Open parenthesis, we put our proven endogenous variable here, which is the GDP log. So GDP log is equal to government expenditure log, which is our now valid and strong instrument. Then close parenthesis. Boom. That's it. That's our final estimate, the 2SLS regression. So as you can see, our GDP log here is statistically significant. Also, our interest rate at here is at 0.05. Also here at 0.05, and here is 0.1, 10%. So, but anyway, as you can see here, our R squared is empty, like it's a dot here. So as you can see that, I'll go to the Stata website and here. So as you can see here that IV regress sometimes reports no R squared and returns a negative value for the model sum of squares. So in short, missing R squares, negative R squares, and negative model sum of squares are all the same issue. Stata IV regress command suppresses the printing of an R squared on 2SLS IV if the R squared is negative, which is to say if the model sum of squares is negative. So which means that R squared is either negative here.
So that's it. That's our final estimates. Doing all the steps for testing for valid and strong instruments, then Hausmann's test, and then the IV regress to SLS model. So I hope you guys learned something from this lesson. God bless and stay safe, everyone.